All right, I'm pleased to invite up here Patrick Takahashi, Director Emeritus at the National Energy Laboratory, University of Hawaii. Patrick is somebody who's been writing and talking about innovative ideas for how to use the ocean for decades, written several books and many articles on the subject of the Blue Revolution, and today he'll be talking about OTEC.
Thank you, Patrick. You know, it's nice to be kind of home again. I went to school at Stanford. I worked at NASA's Ames Research Center and spent some time at the Lawrence Livermore National Laboratory. So this is like coming home. Actually, I won't be talking about OTEC. And the reason is because our next speaker, Bob Nicholson, is one of the world's experts on this subject, and he will give you all the details you need. What I'll do is I'll discuss why OTEC can be so significant in the long term. And what it is, some of us think, is something called the Pacific International Ocean Station. Picture space and envision the International Space Station. That's a $150 billion almost misadventure. It'll slowly be abandoned, I suspect, even though the private sector is trying to get there. But the point of space is why? Why today? Someday, you know, I used to work for NASA, so I'm not anti-space. It's just that the opportunities are on planet Earth, and the ocean is the next frontier. And so we would like to spend only 1% of the $150 billion in something called the Pacific International Ocean Station. And I'll tell you what it's all about. Okay. This talk is being given by 5 different people who are on the board of something called the Blue Revolution Hawaii group. And you can read who they are, but you know, these are very eminent people, and I'll leave it at that. In the Pacific Islands, we have no fossil fuels, which is, I guess, in a way good, but we have the ocean around us. We are also kind of isolated. But, you know, there's huge potential. This is the Blue Revolution vision, and it's very similar to seasteading. We are almost identical twins with totally different missions. Seasteading hopes to do commercialization right away. Our group thinks that we have a lot to learn yet, and so we will be developing some of the technologies and systems that will take time, that will ultimately be adopted by groups like Seasteading. So we are ideal partners in this venture. In fact, maybe one of the headquarters might well be on the Eurasian plant ship that we envision. So anyway, you know, you can read this. No sense me going into any great detail. Today, the world uses 15 terawatts. That might not mean anything to you, but the potential of OTEC, according to an eminent researcher, at least as a friend of mine, I think is eminent, Gerard Niehaus of the University of Hawaii, he thinks the potential is 25 terawatts. Now, and this is continuously, without hopefully affecting the environment negatively. And one of the advantages of this Blue Revolution concept is that we hope to improve the environment, and we'll see how. You have to understand that Professor Niehaus is a real pessimist. So if he comes up with 25 terawatts, this is very, very meaningful. And it's the red areas sort of around the equator that are best located for the concept of ocean thermal energy conversion, which Bob will go into. One of the interesting facts about the ocean is that the deeper you go, the colder it gets. And I won't go into the details of that, but the cold comes from the Arctic and Antarctic. Essentially at 1,000 meters, the temperature is 4 degrees centigrade. That's really cold. So we can bring this 1,000-meter fluid to the surface and match it with the warm surface waters. This is a temperature differential that will give you the energy. And again, I won't go into the technology. But you can see the huge advantage of this deep ocean water. For one, it's very high in nutrients, and the difference between the surface concentration of these entities and the deep ocean is significant. And the reason why they're so high is because life began at the surface or in the photozone, and it eventually died and dropped and decomposed, and we bring it. It's almost like free fertilizer. Not only do you get the temperature, but you get the free fertilizer. And I'll mention a slide later, but one of the pluses is phosphate. Do you know, and maybe you don't know, that there's peak oil, there's also peak phosphate. It's possible farming could be affected in a not too distant future for a lack of the right kind of phosphates. And it just so happens magically that this deep ocean water is very high in phosphates. So maybe farms in the future could well be in the ocean. In fact, I'm on a board of a company that has found a way to grow terrestrial plants in the ocean. And so we're in the process of trying to, patent that so that anybody who grows land plants in the ocean will have to work through us, maybe. Yeah, here's the phosphate thing. We are attaining a peak, and there is some fear that at some point something significant has to happen, or well farming could come to a huge decline. But let me not go into that too. So ocean thermal energy conversion is what Bob Nicholson will talk about. And I showed you where it's feasible. Let me just not go into that. The benefits are here, and you can quickly read them. It's not only electricity, mind you. It's not only energy. It's everything else that comes with it, whether it's next generation fisheries, marine biomass plantations for green chemicals, exciting new habitats for future living. You can go down a whole list of potential co-products. This is the Natural Energy Laboratory of Hawaii. If you land in Kailua Kona, you'll be right next to NELHA. The authority here is where the Pacific International Center for High Technology Research produced 20 net kilowatts of OTEC. It was about 20 years ago now. And proved that open cycle works. The advantage of open cycle is that you get a lot more fresh water from it. This is a current Lockheed Martin experiment where if you just add a turbine, you can finally get some electricity from OTEC. And I'll go into what I mean by that statement later. And I'll skip the technology, Bob. You're going to go into it, right? Now, one option that is potentially important in the Blue Revolution is mariculture, as we can imagine, because here, this deep ocean fluid, if we can control the disposition in the ocean with free fertilizer, perhaps we can regenerate growth as a new kind of economy. And one of my early papers about 15 years ago was something called the ultimate ocean wrench, where we close the growth cycle for the species that you desire. Now, the final product will not be tuna, because tuna is such a high trophic level consumer that you lose efficiency along the way. For every trophic level that you have to go up or down, you lose 90% of the mass. And so we need to find a species that essentially eats plankton, and then you got your maximum productivity. And it turns out, of all the crazy things, about 25 years ago I had a project with Sun Yat-sen University in Taiwan, And if you go to Kaohsiung, you'll see an aquarium, something called the whale shark. It turns out the whale shark, one, is a shark, it's not a whale, so you can eat it if it tastes good. The thing is that this thing is massive, tens of tons. And we just found out recently that it actually gives birth to babies as opposed to eggs. And so at birth, anywhere from 100 to 300 are created. And when you compare that to beef, where the cow produces maybe one, and you look in the future with closing the growth cycle of the system, assuming that a 1-year-old whale shark baby is edible and marketable, that's something that we've been thinking about. It might not be the whale shark, could well be tilapia for all I know, but we'll see. This is just one of the, what is this thing? oh, it's a cage. I don't know, it's one of Neil Sims' cages, but it's somebody's cage that grows a high trophic level fish, unfortunately. I will not go into detail on how fisheries are declining and, we're in desperation and all that. You all know that by now. And as far as catches, where it's coming from, that's common knowledge now. But there is this fish eating, smaller fish eating even smaller fish and so forth. And who knows what that was. Now, initially, you have to grow high-end products because when you really come down to it, fish is kind of cheap. It's more expensive than beef today, but it's still not like cultured pearls or marine biopharmaceuticals or something Lisa's company will do someday with algae. But still, the higher order commodities are what we're looking at initially. And if you go to this Natural Energy Laboratory of Hawaii Authority, you will find 25 or so companies already doing this, whether it's lobster or whatever. And again, who knows what that was. Abalone is one of them. And, well, this is a very large shrimp. And it's not the shrimp we're trying to sell. We're trying to sell the broodstock and so forth to the world. Oysters. Kona Blue. This one of our speakers, Neil Sims, will talk about what he's doing in Kampachi and so forth. But anyway, this is that Natural Energy Laboratory of Hawaii from the air. And microalgae technology has been high on our list for the longest time because it could well be one of the higher order revenue sources someday. In the mid-70s, I had a project with EPRI using carbon dioxide in algae raceways to do the technology. And so I've been involved with it for almost 40 years. And development is slow, but it's happening. And whether algae can provide jet fuel someday or whatever else you can think about, other people will be talking about this subject too. And so we envision PIOS as a living laboratory for the future of what could be these 1,000 cities in the ocean someday. In fact, I wrote a paper once that said someday we could have 10,000 cities. And can you imagine 10,000 nations in the United Nations? I mean, it's bad enough in 192, I guess. Again, I will not read through it, but as you glance through it, you can see some of the bullets as to what we'll be doing. And so, kind of in a nutshell, this is a cross-section of what will be the Blue Revolution. Some platform at the surface that will be drawing cold water from 1,000-foot depths. And the effluent, and this is a tricky part, the ocean engineering of this cold water effluent has yet to be developed. Right now, you get the cold water and you release it and it drops below the photic zone. So it's almost useless as far as stimulating growth. So we need to find a way to keep it closer to the surface, at least in the photic zone. But eventually you'll have next generation fisheries. You will have marine biomass plantations and everything else you can think of. Yeah, let me just skip that.
Can I interrupt with a question?
Sure.
Why does the water drop back down? If you've taken the energy...
It's density. Cold water is dense relative to warm water, and it just sinks. And it sinks too fast. We might have to put a plastic layer, maybe. I mean, there are ways to do it. It's just it hasn't been done yet. But then you put a plastic layer, what about a hurricane? So, life is not that easy. What you want to do, actually, is to put this platform at the equator, because the equator has never seen a hurricane pass through it. Can you believe that? Hurricanes don't get through the equator. So around the equator is a really safe spot to put these devices. And you would want it at the equator, because that's where the surface waters are the warmest. So the future is easy. It's the now, the development, the risk. That's the problem. And this is just a drawing from Shimizu from Japan. And they have this green float concept. That's what they envision as part of their future. And so we've been collaborating with them, and who knows? It's another shot of what they want to do. We have a team. It's almost like seasteading. We have a team that is composed of volunteers and so forth and so forth. People like you, in fact. We have to partner for this, and at this point, it's purely because we think this is the best for humanity. Hopefully, it'll be more remunerative in the short-term future. And we've signed various memoranda of agreements, and it's sort of academically based right now, but that's going to have to expand into companies and countries and so forth. And we have a whole series of people advising us. Some names you might know or not. They essentially are the tops in their field when it comes to things like OTEC and offshore aquaculture and marine law and all that. So we hope to go through this list in the very near future. In fact, we are stepping through them already, and we see a lot of progress. Mahalo means thank you, and this is our advisory group, basically. It's in the Ocean House in Waikiki, so it's appropriate. And let me close it with one more thing, because this is wine country. It turns out that a grape plant, the sensors are in the roots. So you can fool the plant into thinking it's summer or winter. You can control the growth cycle. And it turns out that you got deep ocean water in thin tubes you put near the roots. One is that if you're in a humid location like Hawaii, water condenses, so you get free irrigation. But two is that by controlling the flow rate, this is I don't know, it doesn't look like Chardonnay to you, what you drink, but this is a Chardonnay grape that we grow there that began to bear fruit at 2 years. Normally it takes a lot longer. And we can get 2 crops a year. And so just think of the future of agriculture with some of this cold water technology. So these are the kinds of things we are exploring. And with that, thank you. Any questions?